First things first, my friend Tracy asked me to say hi to Lynn right there, who's like 3 back. She's a friend of Tracy's, I'm a friend of Tracy's. Everybody's a friend of Tracy's if you've ever met Tracy. Right, so by show of hands, who likes to show their hands at conferences? Well, who here has hands? Nice, nice, okay. So how many people here are actually already using RxJS? Quite a few of you. Okay, that's good. Out of that group, how many people here find it confusing at times? I'm the author, and I do that sometimes. I actually did find it confusing at first. This talk was supposed to be a talk about RxJS basics. Honestly, there's a lot of material on that out there already. You folks are in an Angular conference. Angular 2 has just tons and tons of content on observables. There's more important content that I, as one of the lead authors on RxJS, want to get out there, and it's how to think reactively, how to deal with this kind of new programming paradigm that is confusing for, honestly, all of us when we first start. As he said, my name is Ben Lesh. I am the RxJS 5 project lead author. In general, just I keep the project moving. There's a lot of great people that also work on that project. I'm also a senior engineer at Netflix, and you can find me on Twitter at Ben Lesh. If you have questions about RxJS, my PMs there are open. You can send me messages. I usually try to respond to everybody if I can. All right, so more questions. How long have you been using RxJS? So who here has been using RxJS for longer than a month? Yeah, okay. Longer than 6 months? Longer than a year? About 2 years? How about longer than 5 years? No, that's not even me. So it actually has been around that long. Myself, I've been using it for about a little more than 2 years. This project, this library, is actually more than 9 years old. It was started by a guy named Matt Pawłowski, who is actually of Polish heritage, lives in the United States. It was originally part of Microsoft's Project Volta, so that's where the logo actually comes from. And Microsoft's Project Volta was a project aimed at getting C# to compile to JavaScript. And so since Rx.net was a very popular library, they wanted a compilation target with JavaScript, and it gave us RxJS. So when I first saw RxJS, when I first started using it, the questions I've asked. So the first one I asked was, what the hell is this? Is this another Lodash? Like, why do I need this? Because it's what it looked like when I saw it sprinkled into code. And then after I got into it, there was the, what operator do I use for this? Like, what function on Observable do I want to use to do this fancy thing? And then, of course, because I came from an Angular background, I've actually worked with almost every major framework now. But people talk about the Angular way, and so I thought to myself, well, how do I do this the Rx way? Like, what's the reactive programming way to handle this stuff? And then there's other questions, like I put a catch on this observable, why did it die? Like, I don't understand. Like, I caught the error, it should keep going. And then, of course, what's this Rx code I wrote 4 months ago actually do? Like, I probably should have commented. The answer there is to comment your code. So I can answer a few of these, but I want to start with kind of one of the more important things, which is thinking reactively. The thing about thinking reactively versus like how we're used to thinking about coding is we're used to doing imperative coding. JavaScript is an imperative language. And what that means is you have a lot of code that's if this, then do this, stuff some data in this state over here you some more code, if this, then pull the state out and do something with it. So you have this kind of imperative code, it's what you look at every day. Rx is declarative code, so it's a little different, a little bit more functional. So what you need to do, since Rx is all about these observables, and observables are just sets of events. So you can treat events or any data that happens over time, any sort of value over any amount of time, you can treat them as sets. And sets can be manipulated. They can be filtered and mapped and joined together and concatenated, that sort of thing. So you have to start thinking about all of your events as you get them, the things that you're trying to compose together as dependencies. You have to try to identify them in the problem you're trying to solve. So if we look at a problem that we might try to solve with Rx, like drag and drop. Drag and drop, and I'm just going to read this right here. If you just wrote down what you were going to do with it, it's for each mouse down on your target, you start listening to mouse movements on the document until a single mouse up on the document. So you start listening on the mouse down on the target, and then you have all these mouse movements over the document until you let go, right? We're actually composing 3 different things here. So there's mouse downs on the target, there's mouse moves on the document, and there's mouse ups on the document. There's 3 different sets of events that we need to compose together to create this behavior. And we would create them like this. If I was just going to do it with plain Rx, this isn't Angular 2 specific. This could be for anybody's framework. You could create these streams of events like this. First off, I'm going to select my target, just the DOM element, and then I create an observable of mouse down events from my target, one of mouse move events from my document, and then one of mouse ups from my document. And these are observables, okay? And I want to be very specific about this, and I might say this a few times during this talk. Observables don't do anything unless you subscribe to them, right? They're basically functions. Just because I made them doesn't mean they're going to actually add an event listener to anything or do anything until I call subscribe. So what I'm going to do now is I'm going to try to work my way backwards. I'm going to look at the second bit of event composition here, which is mouse movements on the document until a single mouse up. Well, in Rx, that's actually fairly straightforward. We take our document mouse moves, and we use the take until operator, and we give it document mouse up. Now, let's read this again. Mouse moves in the document until a single mouse up. Mouse moves take until doc mouse up, right? And it's only going to listen to the first one of those in a take until, and then it's going to stop listening to mouse movements. So this is going to return a new observable that is basically that, document mouse movements until a document mouse up occurs. And then we look at the first half of it, which is for each mouse down on the target, then we start listening to this. So for each mouse down on the target, we start doing some other asynchronous thing. So that's going to be target mouse downs, and then we're going to SwitchMap, which basically says inside of there I'm going to return a new observable, a new set of asynchronous things that I want to kick off every time someone gives me a mouse down on my target. And what do we want to kick off? Well, we want to kick off the thing we previously made. The document mouse moves take until document mouse up. This is it. This is drag and drop. Now, you probably go through and add a few other things in there, some do's to add some side effects to make the animation for the drag or something like that. But at the end of the day, this is the meat of drag and drop. And that's kind of how you would have to think about it to go through and build this out of observables with RxJS. So let's look at more thinking reactively. If you were to go look at any program you've ever written, and you look at the variables that are in your program, if you just arbitrarily pick where you're creating a variable and setting it with something, it can actually, if you're just to put a breakpoint there and log it out, or just add a log statement right after that, you would see the log update over time with probably different values. Just maybe it does it once, maybe it does 100 times, maybe it doesn't do it at all. Guess what? That's an observable. What's an observable? It is a set of events, a set of values, right? So if that's true, then if I was to go into some code and I find this, and this is exactly the sort of code everybody writes, do something, right? But if I was going to go find some random section of code where I am setting variable c here to a plus b, I could naturally assume that the reason I hit this line of code is because a or b probably changed, so I need to recalculate c. And then I want to do something with c. So if I was going to change this into reactive programming, what I would go about doing is I would say, well, we want to call do something with c, so if I had a stream of c, which is my c $ here at the bottom, I could subscribe to it and call do something, right? So I would get C's in, and they would call that function. And I have to get my stream of C, and we know that C is calculated from A and B, so that means I need a stream of A and a stream of B to somehow combine into my stream of C. So again, I'm kind of working my way backwards. And so if I had a stream of A and a stream of B, I could take my stream of A and use it with combine latest on my stream of B, and provided a function that added it together, because that's what I was doing to get C. And now I have a stream of C. So this is what I would do to convert it to reactive programming. Now, you'd look at this and you'd think, well, that's a lot more code, Ben. The one up the top is clearly just a few characters, and this one down here is kind of a paragraph of stuff. But the difference is, right now, I could change out my stream of A or my stream of B for any other observable that happened to be the same type. So presuming that these are both observables of numbers, and they're probably coming from, I don't know, maybe somebody updated a text box or something for my stream of A, and there's another update of text box for my stream of B. If I wanted it to be updates from a WebSocket, I'd just get an observable from a WebSocket that gave me numbers. I could swap anything I wanted, mouse movements, whatever I wanted, as long as it gave me an observable of numbers, I can just declaratively, I could just go in and change that, and it would work, or I could merge it with another thing. So it's a lot more flexible to go about this way. We've kind of separated everything into something that can be replaced easily. But the important part is that when you're thinking reactively, you have to kind of think of your end result, and this is what I want, and kind of work your way backwards, building out the streams that you need in order to get the stream that you want. So on the heels of that, another one that I get is, oh my God, RxJS is so confusing. Usually this is people freaking out about what do I do? How do I do this thing with RxJS? First off, if you're new to RxJS, stop worrying about the operators. The operators are all the little methods that are on the USC map, flat map, SwitchMap, these sorts of things. If you're new to it and you find these things confusing, by all means go hit the documentation, but when you're just starting to use it yourself, stop worrying about all of the operators. You can worry about maybe just a few of them, and I really mean it. Seriously, stop worrying. Like, the operators are the most powerful part of RxJS, but don't freak out because there's 60 of them, okay? You're probably not going to use all. I haven't used all 60 of them, honestly, in production code. They all exist for a reason, but I haven't hit all of those reasons yet. So, to simplify this further, if you were familiar or comfortable with promises, one more hand raise, because you guys love raising your hands for me. How many people here have used promises in their projects? Right, because I would bet a lot of you probably use Angular 1, and there's promises everywhere in most Angular 1 apps. So if you look here, you get at the top, this is promise usage. You got promise then, and it gives you give it a success handler and an error handler. Well, Observable has subscribe, and you give it a next function, which is every time you get a new value that comes in, an error handler, and a completion function that tells you when it's done sending you values. All right, so it's very similar. It's just got one extra function to it. But the real truth of this is, the joke of this is, really most people only ever end up using the first callback, for the most part. I mean, sometimes people will use the error handler and then, but usually they use catch or something. This is what you're most commonly going to see. And now they're pretty much the same shape. If I went in and renamed them to something else that looked kind of similar, like Quick Draw McGraw and Quick Draw McDraw, it looks exactly the same. It's JavaScript. You could do this if you wanted. I don't recommend it. Or if you do, please send me the repo because I'd love to read it. But yeah, without operators, if you don't have all these operators chained on, they're really no scarier than promises, really. So try not to worry about the operators, but you can probably start by getting your feet wet with map or filter. Those are two things that a lot of people are familiar with from arrays. That's a good starting spot. Maybe, unless you're still too scared, it's fine. It's fine. Send me a message if you're still scared after you try map. I'll try to help. So the next thing that people run into is they start getting into more operators. So they got comfortable with filter and map, And maybe they've learned flat map, which is a little exciting, or SwitchMap. Those are pretty common ones. But then they hit some weird problem, and they're like, oh man, what operator do I use for this? I'm going to recursively crawl an async tree, and I know that Rx is probably really good at that, but I don't know how. Remain calm, it's okay. Don't freak out about the 60 plus operators. We've got things to help solve operator agony when you're agonizing about what operator to use. First of all, there's an operator guide in the docs, which are located at this URL. It's reactivexio/RxJS. What that does is it gives you this kind of guided, asks you a bunch of questions about what you're trying to do, and will guide you to an operator or more than one operator that might work for your scenario. The other thing to remember is you don't have to Rx everything. You simply don't. You can just take the operators to the point to which you're comfortable, then subscribe to it, get the data out of the observable, and use it imperatively like you're probably already comfortable with doing. People already do this with promises. They'll get a promise, they'll vent it one time, and then they'll start doing imperative things with it over here. They're not making these crazy promise chains that they could. And maybe even they should in some cases, but for the most part, people are comfortable with kind of an imperative thing. So, and I bring these things up because sometimes people lament, why is Angular 2 using RxJS? They're using RxJS because it fits a lot of needs. Any type of asynchrony you could want to deal with, RxJS handles it very, very well, and it's got things like cancellation that promises don't have. But then people get bent out of shape about it being hard or difficult because there's all sorts of operators. Don't sweat it. If you do end up going to the docs and you're trying to find the guided, which operator do I pick, it's at the bottom here. I just wanted to bring that up because it's not really readily apparent to some people that that's where it is, but there it is at the bottom. Start clicking through, answering questions, and it'll lead you to the right operator. If I'm going to recommend operators to start with when you're learning RxJS, I would start with these. So map and filter, obviously. Scan. Scan is like reduce. So if anyone's ever used a reducer, if they're used to Redux, or actually scan, you can implement Redux stores with in one line of code. It's a Redux store, basically. Maybe a few more than that. Redux stores do some awesome stuff. But basically, scan is a Redux store where you give it a reducer, and it actually emits the changed state every single time. Then there's merge map and switch map. Switch map is a really important one. I would get familiar with that. And then things like combine latest, concat, and do. So these are just ones I would recommend starting with if you're just getting used to RxJS. So the next thing I want to talk about in this talk is demystifying observables. Observables are a class. You new one up. It's got all these methods on it. If it has that many methods on it, it must be doing something amazing, right? So what's inside of observables? Complex async things that boggle the mind. Nope, I wrote it. I'm not that smart. Dark magic and unicorns. If I had a unicorn, I would not be standing up here right now. I would be riding my unicorn. I don't know dark magic, so not that. I'm not a rocket scientist. So none of these things exist inside of observable as a type. What if I told you that observables are really nothing but functions? So they're just functions, and they're kind of wrapped in a class. And I'll prove it to you. This is an observable. An observable is a function that gives you an observer. So it's a function that takes an observer. That's an observable. And you do things with the observer inside that function, like call a few methods on it. So in here, I've got an observable that's going to set up an interval and next out 10 numbers, starting with 0 and ending with 9, before it completes. And how I do that is I set up the interval, and then I call observer.next, and I next out numbers. And then I can also call observer.complete when I'm done. So I could call observer.error if I had an error in here, but I'm not going to error in this. This is pretty straightforward. So this is basically what an observable does. And the one other thing that it does is you can return a function that has your teardown logic. So in this case, if I set an interval, I want to be able to tear it down at some point if my user decides, I don't want your 10 numbers, Ben. I want to kill this thing. So we're going to return a function to them that they can call later. So to use it, I would use it like this. All I need to do is pass in an object, a simple object that's got a next method, an error method, and a complete method on it. That's an observer. So I pass my observer in. So it's down there at the bottom, and that's the observer pass in, and that's what I'm calling next and complete on inside of there. And we know that it's returning that teardown function that I can call later right there. So that same function that's doing clear interval, it's going to get returned out, and I can call it at some later point to kill my observable. So right now, I've got an observable, and we could write a whole observable library just like this with functions. Wouldn't that be great? Well, if we're going to do that, we're going to need operators. So we're going to want to have map and filter and all these things so we can do cool stuff with it. An operator is really a function that takes an observable and returns a brand new observable. And what did I just tell you about observables? Observables are functions that take observers, so we can swap that out. So now we've got this higher order function, right? It's an observable that returns a function that you give an observer to. And then operators, it's going to actually subscribe to the source observable inside of here. So the job of what an operator is going to do is it's actually going to take that source observable that we provided as part of our higher order function and subscribe to it with its own observer, which is that plain object there in the middle that's got a next method, an error method, and a complete method on it. And then what it ends up doing is it ends up forwarding values that come through that next error and complete along to the destination observer, which is the one that's provided to the resulting observable. So it's chaining observers together. So let's make this a map operator. In order to make this a map operator, all I really do is I add an argument there to provide a mapping function, and then I make sure to call the mapping function on the value before I forward it along to that destination. So that's it. This is a map operator in a nutshell. If you go and you look at the RxJS 5 source code, there's a lot more code than this because I'm optimizing things for V8 and I've got some safety mechanisms in there, right? But in a nutshell, this is what the map operator does. So let's try to use this. If we try to use it, it's going to get used like this. We're calling map on an observable, and we provide a mapping function. And we can go ahead and use it, and it'll spit out 0, 1, 2, 3, and add our exclamation point to it, because that's what our mapping function was told it to do. All right, let's chain a couple. If we chain a couple, then it's getting kind of weird. We've got a map. We're calling map on the result of another map. We have to provide two different mapping functions. It's not so easy to read, but it works. It'll spit out the right stuff. But what happens when we want to have like a couple maps and a filter? We really want to build out this chain. It's pretty gross, right? Here we're doing a scan, and then we got a filter and a map, and we got all the arguments going the other direction. We're kind of building out, I don't even know what this is. Maybe if we format it, it'll be better. Nope. It's still pretty nasty. So it would be nicer to have an API that does DotChaining. So DotChaining looks like this, where you have some object and then you call dot some method on it, and it gives you back the same shaped object, and you call dot some other method on it, and so on. This is DotChaining. And since all of our operators return observables, this makes sense. We could probably do this, maybe with a class. So let's wrap our observable functions in a class so we can have this DotChaining behavior. So what do? We create a class. Into our constructor, we just provide that same observable function that we were creating before, the identical function. I'm just going to stuff it on a property I'm going to call observable fn. And then when I create a new observable, I say new observable, pass the same function that takes an observer in down there. And then when I want to subscribe to it, and when I want to call it, I would call my observable fn. Well, it's kind of a horrible name for an externally facing method. So why don't we just stuff it in subscribe instead? So now we call subscribe, and now this looks like the observable you're used to seeing in RxJS. We're calling subscribe. Now, the observable type in RxJS does a lot of other things that provide safety, but this is what it's shaped like, and this is kind of why. And then we want to add our map operator to it. This is exactly the same map operator we had before, but instead of providing the source observable as an argument, we just use this. So it's this.subscribe, right? So it's the same, this is the same basic thing. And now that we have that, we can chain our map operators together. Simple as that. Now I'm going to add an exclamation point, then a question mark, then a period, because I really like punctuating stuff. And when we run it together, there we go. It's going to work. So observable as a class, the reason it's not a function is it provides DotChaining. It provides the ability to add safety to the type. And what I mean by that is I can take your next handler that didn't get an error handler or a completion handler and kind of stub some of those in. I can add other bits of safety, like making sure that next can't be called if complete has already been called. That wouldn't make sense. Here's a value, I'm done. Just kidding, here's another value. Right? So you got to add some safety in there like that. We can provide some performance optimization since we have a class. If you give me an observable of one scalar value, so one value that's going to happen synchronously, then I know I can check and be like, oh, is this a scalar observable? Great. I can just pull the value out right now and map it that way. I don't have to build a subscription around it or anything. But the important thing that you need to remember is really it's just wrapping a function. Calling, it's the same as saying function.call and then doing something. Observable.subscribe does something. Observable just sits there as a function. Functions don't do things until you call them. Thank God, our jobs would be really hard if they randomly did stuff without you actually calling them. So think of observables as functions. That's all they are. Really important. Another term that you'll hear about this is lazy. Observables are lazy because observables are functions. The other important takeaway here is that operators take your observable and return a new observable. So I'm going to look at the operator really quick here again, and I want you to notice something else. So operators return a function, aka an observable. So it's lazy. It's not going to do anything until you call it, until you subscribe. But what that's actually doing on the inside, that creates an observer that passes values along to another observer. So it's creating a chain of observers, okay? So you've got this, your observable is really just this template to tell your program how to create a chain of observation that does something. So an observable chain, if we're going to look at, we've got an observable and two operators and then a subscribe on the end, looks like this. Each one of these steps would have a different observer. There's a safe observer that comes from your data source there, that top observable. That's the thing that it's going to be provided to new observer. The observer that's provided to your new observable function that you're calling to emit values. There's one for your filter operator that's starting a chain of like do this and then carry on to the map observer. And there's another one finally that wraps your handler here at the bottom. So we've got 4 observers in this chain. So if I was going to visualize it, it's going to look like this. It looks kind of like guitar strings or something. And these boxes represent observers. And the 3 lines represent your next channel, your error channel, and your completion channel. These are channels down which events will propagate in your system. So we've got one for the producer at the head, one for the filter, one for the map, again, and one for the subscribe. So what's going to happen here is in an interval, intervals provide values like the interval observable will give you a value like 0, 1, 2, and so on. So, and it never ends. So what's going to happen here is the first value it's going to provide is a 0. So the 0 gets sent into that observer's next and forwarded along to our filter observer. Our filter observer is going to make that assertion on 0, and it passes. And it's going to forward it along to map, which is going to add 0 and 0 together, which is, of course, 0. And then forward that along to our handler. Whatever it's doing, it's going to do it. Log it out or put it in the DOM or something. But the next time we come through, we get a 1. The 1 goes and hits our filter. It doesn't pass our filter. So guess what? We just don't forward it along. It stops. And the pattern continues. So what about error handling? We just did everything down the happy path up there. We were only really lighting up that next channel. So there's a rule about observers. I mentioned this a little bit earlier. Observers will no longer pass along a value if error has been called, complete has been called on it, or the attached subscription has been unsubscribed. So if your consumer is like, no, I don't want to listen to your stuff anymore, stop sending me values, observers will no longer be functional. They go inert, they're dead. So what does that mean for error handling? So let's just say I've got this contrived example up here where I've got an interval, and I'm saying, hey, if x equals 1, which is the second value that's going to come out of our interval, throw an error that says, haha. I write code like this all the time at Netflix. They love me for it. I don't really. If you're watching, I don't do that. It wasn't me. So what's going to happen here is we're going to send through the 0. 0 makes it to our map, and the map isn't really even doing anything with it. It just sends it along to the subscribe. That's fine. Then we're going to send along the 1. Well, that's going to hit our if block here, our if statement, and it's going to throw our error, haha. And that's going to kill that filter observer, because the filter observer is then going to call the error handler on itself, and as soon as error is called, guess what? It's done. So that means that nothing else can pass through it. Everything upstream, that interval that was going upstream, it has to stop. It actually unsubscribes from that interval, and the interval can no longer send anything down. Then we send our error message down the last remaining leg of this to our error handler in our subscription, and it's done. So how do we solve this? We solve this with the catch operator. So the catch operator works a lot like promises catch. Promises catch, it gives you the error and you're expected to return a promise. In this case, you're expected to return an observable. So using catch works like this. First, we're going to send along a 1. In this case, I have a map that's going to throw every time, because it's the worst code ever. I don't know who writes that, but here we go. Map throws, and everything above it dies. But the error goes to the catch observer, and the catch observer is going to do something interesting. Now, it's still calling error on the catch observer, so that catches observer is dead, because he called error on it. It can't do anything else. But it's going to call that function you provided to it, and it's going to map to a new observable that we then swap in and subscribe to. So then we get an observable. This is an observable, just the value 2. The 2 gets forwarded along, and then it completes because it's done. It's just observable of 1 value. And we're all done. My clicker's freaking out. All right. So I think that's where we were. Yeah, so we're done. Sorry about that. So, but catch still let the whole observable die, right? So that's one of the problems I mentioned earlier. Why did that observable die? I put a catch there. That's not how catch works. Yeah, it actually is. So the way we fix that is by isolating our observable chains. So let's say we have an interval we don't want to die. So this is a common scenario. You've got an interval. You're saying every 10 seconds or every 30 seconds or whatever, I want to send out an HTTP request and pull something, like over time. And what happens if that HTTP request 500's on you, or it goes 404 for some reason? That's an error. But we still wanted to keep polling. We don't want to kill the interval. So the most common way people try to solve this is by just adding a catch after our SwitchMap, where we're trying to merge in our results of our HTTP GET. This is probably not going to work, but I'll show you why. So first we send along 0. We'll say 0 goes in, and it's going to switch map to a new observable for our HTTP GET, which starts a brand new observable off to the side. It subscribes to it and forwards the values back into your main observer chain. So we're going to say that this one successfully sends a value. So it successfully sends a value along that we forward to our catch, which doesn't do anything with successful values and just passes it along to our subscription handler. Now let's send in a 1. So 1 comes in some seconds later or whatever, and we're going to map that, or we're going to switch map that into a brand new observable again for our next HTTP call. This one I'm going to say errors. When it errors, its observer dies. It's going to forward along to SwitchMap's error channel, and SwitchMap's error channel also dies. or causes that SwitchMap observer to die, which means everything from SwitchMap up in both directions goes away. That interval is dead now. It's not going to get fired again. It then goes to catch. In this case, I'm having catch return observable.empty, which is just an observable that completes right away. It doesn't give you a value. And so it's going to map to that, forward along our completion, and we're done happily. Sort of. Except for our interval stopped working, and that's not what we wanted, right? We wanted to try again, even if it gets 500s every so many seconds. So you're dead. Haha, too bad. I designed it this way just to troll the world. No, actually, what you probably want to do is take that catch and stick it inside of the switch map. So let's see what happens in that scenario. So in that scenario, we're going to say, and I'm just going to jump to the part where it errors here. We're going to send our 0 along from our interval. We're going to switch map that into a brand new observable. Now you see it's got 2 steps because it's got our HTTP get and then it's got a catch right after it. So we're going to say that that get errors 500, whatever. Sends it along, so that observer dies. Sends it along to the catch. The catch observer dies because you called it the error handler on it. But it's going to map to a brand new observable of empty. And that's going to happily send along a completion. Now, here's a trick. SwitchMap does not die just because one of its child observables completed. SwitchMap will only die if its source observable and all its children complete. That's the only way it'll complete itself. But intervals never complete on their own, so this just gets swallowed. Right? And look, our observer chain down here is still happy, it's still going. Which basically means that when the interval fires, it's going to map to a brand new observable again, and you get the idea. So what we did is we created a second observer chain, and we punctuated that chain with a catch. And that catch shields that main observer chain, so you keep it from dying. So the TLDR, the long and short of it is, when you're trying to handle errors and keep an observable chain from dying, you probably want to put the catch inside a switch map. So the next thing I see quite often when I'm helping people, they have memory leaks. And they have memory leaks because they have subscription management mistakes. They fail to unsubscribe. So unsubscribing is important. It's the same thing as doing add event listener and remove event listener. If you add an event listener to the DOM, you need to remove it, otherwise you create memory leaks. This is a web development 101 sort of thing. It's very important. So unsubscription tears down resources. If you have an observable of DOM events, you need to unsubscribe from it if you subscribe from it, or subscribe to it, because you need to remove the event listener that's making it work under the hood. If you've got a WebSocket, you need to close it. If you have an interval, you need to clear it. So managing these things is done imperatively. We get a subscription back, and later on we can call unsubscribe. This is imperative programming, not declarative like most of RxJS. If you want to manage these things imperatively, you can, if you have weird code that for some reason lines everything up like this, it becomes a little bit easier. But I've got subscriptions 1 through 8 here, and I've got subscriptions 1 through 8 there, but I'm missing one. Which one is it? I don't know. Well, I do know because 4 was missing and because all those were lined up really nice. But the truth is, in the real world, your code is not going to be lined up nicely like that. Your subscriptions and your unsubscriptions are going to be sprinkled all over the place. So managing your subscriptions imperatively means you're more likely to miss and unsubscribe. It doesn't mean it's wrong. You can still do it that way. But you're more likely to miss and unsubscribe. So there are other ways. One is you can manage mostly declaratively. You still end up having one subscribe and unsubscribe here. So this is one where you could merge all the observables together, and you can use take until to kill observables. So that means you can fire some event into another observable that tells some source observable to stop working, right? So this is one way to do it. Another way is you could compose them all together under one subscription. That's still a little bit imperative. This is cool, though, because I could use DOM events, route changes, a subject, anything. Any sort of event I want to, I could compose together. I could use to kill my other observables, to unsubscribe from them. There's quite a few operators that allow you to do this. Take until, take while, take first. Switch and SwitchMap have some tear down semantic to them. So there's advantages to this. You have fewer subscriptions to manage, probably one or maybe two. You're less likely to miss and unsubscribe. You can use any stream of events to kill your observable, and there are many, many composable ways to do it. There's yet another approach to subscription management. Let your framework libraries or libraries handle it for you. In Angular 2, there's a thing called pipe async, or the async pipe, or however you want to say it. It looks kind of like this here at the bottom. If you look at your template and you see this foo $ is a stream is an observable stream, it's an interval, and if you see pipe async after it, Angular is going to automatically subscribe to it when it hits the view, and when it was removed from the view, it'll automatically unsubscribe from it. So you don't have to manage any subscription yourself. But there's a gotcha here. So let's say I have an observable source. It's a single observable source that I'm going to map into two other properties, foo $ and bar $. But it comes from one single observable source. The gotcha here is that I'm going to stuff this do here so you can see whether or not the timer's fired, because this observable timer is only going to get fired one time. And the gotcha here is that if I've got two pipe asyncs to these two different observables that come from one source observable, it's actually going to subscribe to that source observable twice. So you'll see in this code scenario, you'd see timer fired twice. So source has been subscribed to 2 times. There's an easy workaround for this, actually. Just add share to that observable. What that does is it multicasts it. It says everybody that's observing me just observes one of me. I'm not going to subscribe multiple times. But fair warning, multicasting comes with costs. That means you have to maintain an array of observers at some point, somewhere in there. So there's a little bit of extra overhead to that. So if you're doing it all over the place, you might see some performance hits. Just regular unicast observables are going to be a little bit more performant. So pipe async, the pros are no subscription management at all. So you're not likely to have any memory leaks from that. And you've got automatic unsubscription when your component's unmounted from the view. The cons are it encourages overuse of multicasting at times. So it's something to be aware of. I have a subscription rule of thumb for me. If you find more than 2 subscriptions you're managing in your component, then you probably have too many. The very last point I want to make, do not Rx all the things. Actually, the first talk I ever did in the Angular community was with Martin Gontevnikas, and we were talking about Rx all the things. Yeah, don't do that. You could actually build your app as one big observable. And I've seen this. I saw a code REPL, so it's got like autocomplete and everything. You're typing code over here, it's executing over here, written as one big observable, right? You call subscribe and the whole thing starts working. Because observables can represent anything that's got setup and teardown and is any number of values over any amount of time. So think about what that could be. Pretty much anything. And that's what they made. Don't do that. I told the person that wrote it, I think you, me, and 7 other people in the universe can maintain this now. Your teammates will likely hate you if you Rx all the things, or maybe they'll love you, I don't know. But I would advise against it. Use Rx where it's best suited. Composing multiple events together, adding some sort of delay or client-side rate limiting, coordinating multiple async tasks like we saw with drag and drops, very good at that. When cancellation is required, dealing with streams of events and stuff like that with WebSockets. Don't use Rx when it's not needed. If you've got an app that all it has is you click a button and it does a thing and you don't have Rx in there already, don't bring a whole library in just to hook a button click. That's silly. Basic forms use. If you don't already have Rx in there because you're using something like Angular 2, don't import a huge library to deal with simple things. Use it when you need it. Hello World apps. I've actually seen a Hello World app that had Rx in it. I don't know why. So, just to recap, thinking reactively, you want to work backwards. Any variable could be an observable. Observables are just functions. Observer chains do all the work, not the observable. The observer chain itself is the cool part. Calling error breaks the chain. So if there's an error anywhere in there, it's going to kill everything up above it. Know your subscription management and use Rx only where it makes sense, okay? So thank you very much.